Okay, now, I said it, but I killed the video because I did this in a way that I think is a little confusing, just for a minute. So we just started over. This is a constant plus some constant multiple of v squared, which automatically invokes the 1 over 1 plus x squared integral, which is the arctangent of x. Okay? One of the basic derivatives that we should know is that the derivative of the arctangent is 1 over 1 plus x squared. Hopefully we know how to use a chain rule to derive that, but still, there it is. Okay? Okay, so we have this. So we want to put this into a form that makes it easy to substitute and get a 1 plus u squared in the denominator. Okay? And what we first do, we want to get a 1 here. We got an f here. So what do? We just factor the f out of the denominator. So now our denominator within the integral is 1 plus kappa over f times v squared. And of course, if we multiply that f by the 1 plus the square plus kappa over f v squared, we get back to this. So just checking ourselves, right? Okay? So now I'm going to do the substitution. I'm going to let u equal square root of kappa over f v, so that kappa v squared is u squared. Okay? But it's going to be in this form. Okay? Then du equals this, so dv is the square root of f over kappa du. So now I have the integral 1 over f times the square root of f over kappa du divided by 1 plus u squared. Okay? And of course, that square root of f over kappa can come out here, and we end up with 1 over the square root of kappa f. In any case, this is going to equal negative t over m plus a constant. So we're getting then 1 over square root of kappa f arctangent of u okay? Of course, the arctangent of u is the arctangent of square root of f over kappa v, square kappa over f times v, right? So we have arctangent of square root of the whole thing, square root of kappa over f v equals negative one over the square root of kappa f m squared. Now it's just a matter of taste whether I leave the m outside of the radical or put it inside the radical as a square. Okay? But since this is all going to be a constant, why evaluate this constant and then multiply it by m when I can just multiply these and then take the square root, right? That's my thinking on it. I could say negative t over this, and it's wrong, multiplied by kappa f. So it's negative square root of kappa f over m squared times t plus c. No, this is some constant multiple of T that depends on how strong your drag force is. It's a function of V, and inversely proportional to M, okay? And then your applied force, okay? So more drag force, more applied force gives you a bigger constant here. A bigger M gives you a smaller constant. Okay? So you have this, right? So that square root of kappa over FV is a tangent of okay? Okay, well, that's a solution to the equation. Now let's try to make sense out of the situation.